So that leads us to 3.8, adding and subtracting signed fractions. Now, we have to put signed fractions in here because the fractions will be positive or negative, okay? But all the same rules for addition and subtraction of negatives still apply. So just real quick, okay, this is abstract. Common denominators are required for addition and subtraction. But we usually simplify fractions. Once we get common denominators, we usually simplify it into one full fraction. And this is, again, true for addition and subtraction. But you're going to operate just with the numerators, right? And this is because, remember that the denominator tells us the size of the piece, right? Like if we're talking about brownies, sure, B for brownies. Well, the B tells us the size of the piece. So once the sizes of the pieces are the same, you don't need to worry about the size. You just add how many pieces there are, which is the numerator. Or if you're subtracting, right, like you're eating some pieces of brownies, bang, you just subtract them off right there, okay? So we're only really operating with the numerators once we get the denominators to be the same. So this goes back to what we talked about in the intro for the class, right? Is mathematics really just is a manipulation of things to be what you want them to be. And most people prefer not to see two fractions. Most people prefer to see none fractions, but we can't really avoid that right now yet. So if we can just simplify it to one fraction, then we end up with something hopefully that looks a little bit better. And then once we do this operation, by the way, we should be looking to simplify the fraction, whatever it is that we get. So a problem like this one, this is just to get us started, right? Well, we need to look at the problem when it's addition or subtraction, like this one, subtraction. Just look at the denominators, all right? These are the same, and that's good. We want them to be the same, which means that I don't need to find lowest common multiples. I don't even have to find common multiples. They're just the same already. They're common. So if I were to expand on what we just saw on that last slide right there, right, I could rewrite this as a new fraction with the denominator of 9, but I'm going to take the two numerators, 4 and 1, and then I just keep the operation, 4 minus 1. Well, 4 minus 1 is 3, so I have now 3/9. And I should check to see if this could be simplified. Well, 3 and 9 could be simplified because both of these are divisible by 3. So to simplify this, again, just remember, whatever you do to the numerator, you got to do to the denominator as well. 3 divided by 3 is 1. 9 divided by 3 is 3. Well, this can't be simplified any further, so I would just leave this as 1/3. Now, I would check this on my calculator, right? And yeah, so the calculator just confirms that I did my work correct, and we're good. All right, so here's a problem where we do not have common denominators, and one of the numbers is even negative, which should be okay. But I want you guys to try this one out, and I know we haven't seen one yet where we have operated with uncommon denominators, but we've done a problem in the module with uncommon denominators, all right? So see if you can operate on this one and simplify. Take 30 seconds, well, 1 minute. Try 1 minute, and then we'll go over it, all right? So on a problem like this one, I would just use multiples of it just because, again, we expect you guys to know the multiples of 8 and 6, right? So the common multiple of 8 and 6 should be 24. But if you said 48, it's not going to matter. You'd still get the same answer, all right? So this would be using lowest common multiple stuff, all right? So I need to change the 8 and 6 into 24 because 24 is the common multiple for both, the lowest common multiple for both. So we need to be thinking, well, what do I multiply 8 by to get 24? Well, I'd have to multiply it by 3. Well, that would give me, 3 times 8 would give me 24. That's good. But then I'd have to multiply the 3 by the 3 there, which would be then 9. Now I'm going to tack the negative onto the numerator because we don't assign the negatives to the denominators. Otherwise, again, they would be considered uncommon in this case. One would be positive, one would be negative, which is different. So whenever you see a negative, just assign it to whatever the numerator is, okay? Now this one is addition. So now we got to look at the 6. Well, what do I multiply 6 by to get 24? Oh, that's 4. So again, whatever I multiply the numerator by, I have to multiply the denominator by as well. So 1 times 4 is 4. 6 times 4 is 24. That's what we wanted. So now that we have common denominators, we can rewrite the problem with one denominator, which is the same, 24. Then we take the two values, negative 9 and 4, and add them together. Well, negative 9 plus 4 would be negative 5. And of course, we keep the denominator because that tells us the size pieces. And we get negative 5/24. Now, some of you guys saw that I typed that into the calculator in the beginning. That's just to save us some time checking this, all right? So the calculator shows us, and again, I would want to make sure that I've typed it in correct, which I have. I got the same answer for both on the calculator and doing it by hand. So it looks like this is our answer. Now again, this one was nice because, I mean, if you needed to list the multiples of 8 and 6, don't feel bad about that, all right? Or if you found the prime factorization for both, that's still okay. But when we see numbers like this, 8 and 6, anything 12 or below, we kind of want you guys to just know what those multiples are, okay? And again, that's purely for speed. It really has nothing to do with your knowledge of math, all right? So if you're like, hey, look, I don't want to memorize that stuff, I'm just going to use the calculator because we can at this point, all right, that's fine. All right, so here's a problem where about 20 is kind of big, right? And you could say, well, I already know my multiples of 20, and I know my multiples of 8, so 20 times 2 would be 40, which is a multiple of 8, so I could use that. But let's say that we didn't know that, okay? In fact, you could say, well, let's pretend these numbers were a little bit more funky than what we see right here. And that'd be okay. So there's another method for finding common denominators, which is often used. And it's not required that you do it. Some students hate it, and you get to decide, all right? So if I wanted common denominators, what I could do is I could just take the denominator from one fraction and multiply it into the numerator and denominator of the other fraction. All right, so let me expound on that, okay? So like the 8 right there. Well, I could multiply it into the other fraction, the numerator and denominator, like this, to get a new denominator. 8 times 20 is 160. So 8 times 17, all right? Again, I'm not familiar with my 17 multiplication tables. So multiply 8 by 17, and the calculator gives me negative 136. All right? Well, that's a big denominator. That shouldn't matter, though, okay? So I multiplied the 8 into the first fraction because it was the other denominator. Well, the 20 would be the other denominator for the 5/8. So I can multiply the 5 and the 8 by 20 and scale that into 20 to get a new denominator of, we needed that denominator to be 160. So I have common denominators, which means I can now add or subtract with these two fractions. So 5 times 20, 100. Now, was 160 the least common denominator? It was not. Are we going to have to simplify in the end? Yes, we will. But does that really matter? It doesn't, because we'll end up with the same answer either way. And yeah, we're subtracting on this one. So we have the common denominator of 160. And yeah, we're subtracting in this case. So negative 136 minus 100. And what do we get out of that? Negative 136 minus 100 would be negative 236 over 100. So I need to simplify this. How am I going to simplify it? I'm actually going to use the calculator. Of course, you could use basic methods for simplifying, right? You could say, well, I can see that both of these are divisible by 2. And then I'd get negative 118 over 50. It's a negative, by the way. And then, well, this is still divisible by 2. So here we go. So it's a negative 59. Let me fix my handwriting there. Negative 59 over 25. Well, 59 doesn't have any factors of 5, so whether it's prime or not doesn't matter. It's just, that's fully simplified. But let's just double check, right? So I'm going to type it into the calculator. I had a typo back there, didn't I? I read that as 100. It was 160, dang it. That's all right. That's easy to fix there. So 160 divided by 2 would have been... Hey, it's good if you can read your own handwriting, you guys. But I made that mistake, which is okay. It does happen from time to time. So 80 divided by 2, and then, yeah, that gives us the 40. Now, I want to emphasize that we found that with the calculator, right? I suppose some of you guys saw that and didn't say anything, which is okay, because we found it with the calculator. And that may happen on your work as well. When you guys are doing the homework, always just check with the calculator whatever you're doing by hand, because, well, I wouldn't say that's a common mistake, but it does happen from time to time. But yeah, the calculator did confirm that this would be our answer, negative 59/40. All right, here's an interesting one. You guys try this one out and see what you get on it, all right? I'll give you 1 minute. 1 minute, go. All right, hopefully you guys have that. Again, if you're still working on it, just finish up and then check your work with what we get on this, okay? So to start off on this one, since we're only dealing with 2 numbers, just like if it were not fractions, I would change this minus negative stuff to an addition problem. Okay, and that, I don't know, for me that makes working with the negatives a little bit easier, but you don't have to do that, okay? So, well, I should say you don't have to do it at this point. But we need common denominators in order to add or subtract fractions, always. And right now we do not have common denominators. So, you could find the lowest common denominator. Let's say that you guys are committed to that. It's like, I want to find the lowest common denominators, even though I know I could multiply the 2 together, which could or could not be faster. Again, you get to decide. All right, so common denominators, let's look at 8. Well, 8 splits up into, well, 4 and 2. 2 is prime. And 4 splits up into 2 and 2, right? So 8 is 2 times 2 times 2. And then 28, and we can do it over here. 28 splits up into 4 and 7. And 4 splits up into 2 and 2. All right, so if I was looking at 28, I have 2 times 2 times 7. So my lowest common multiple, which is going to be my lowest common denominator, comes from all of my common factors, which in this case is just the sets of 2. So that's 2 times 2, and then all my uncommon factors, so times 2 times 7. Now, if we multiply this in the calculator, we should get 56. All right? So So I need to change both denominators into this 56. Okay, so I'm just going to rewrite this with the new denominator, because whatever I get, I need denominators of 56. Excuse me. Well, what do I multiply 8 by to get 56? Well, we should know that that's 7, because again, we want you guys to know the multiplication tables from 8. Not 28 so much though, right? So that would be a negative 7 over 56. And 19 and 28, again, I would just take 56. If we didn't know what that multiple was, in the calculator I do 56 divided by 28, and that would be 2. So you'd have to take the 28 and multiply it by 2 to get 56. And then 19 times 2, again, you can put that in the calculator. You get 38 on that. So this is my new problem, and since I have common denominators, I can rewrite the problem with one fraction, and it is an addition problem. So I got the negative 7 plus the 38. And then this would give us negative 7 plus 38 is 31. So yeah, we'll put that 31, and I got 56 there. Well, 31 is prime itself, and it's not 56 is not a multiple of 31. So it looks like this would be the simplified fraction. But again, I want to check, and I have it typed into the calculator already. So when I push enter, I should get 31/56, which I do. So that confirms. That makes me feel a lot better about this answer, especially after making a mistake on that last one. So it confirms that the answer is 31/56. I just want to re-emphasize how important the calculator tool is, right? I mean, it's doing a lot of work in there, but you guys can see how easy it is even to type a question like this one, because the two calculators that we recommended for this class have these parentheses buttons. You guys can see those for the TI-30 there. It's just right above the 8 and 9, right? You can put parentheses in just as you see them. So where we're simply evaluating problems like this, even though it has parentheses and negatives, right? And again, we need to distinguish between the two buttons. We have a negative button and a minus button. They are different, and they show up different on the display. But just typing these in as is should not be a problem with the calculators that we recommended for this class. All right, well, here's another one. Let's go over this one real quick. All right. So 15 and 10. Well, I don't know. We want you to know your multiples of 10. 15, maybe not so much, but I don't know. You can find any common multiple of both, but if you want to find the least common multiple for these two, 15 times 2 would be 30, right? And 30 is a multiple of 10. So this one, hopefully, again, whether you're seeing that or not, you could use 30 as your common multiple. I guess, what do you guys want me to do? You want me to use prime factorization, list the multiples, just multiply the two denominators? What are you guys feeling comfortable with right now? Well, if there is no opinion, then I'm going to go with 30 on this case. So I'm going to use the denominator of 30. And again, that's just, and again, it's more for me than you, but if you didn't use 30, that's fine. But I know 15 times 2 is 30. And 10 times 3 is 30. All right, so that gives me a pretty quick common denominator for these ones. So I have to scale both the numerator and denominator. 2 times 2 is 4. So I'd have to multiply the 7 by 3 as well to get 21. And yeah, if some of you guys were like, well, why didn't you change the sign, the operation rather, from addition to subtraction? Because we are adding a negative, you could. Like if you're like, yeah, I want to change that to subtraction, feel free to do it, okay? But if you wanted to keep that as a negative plus a negative 21, that's fine, all right? So we have this common denominator of 30 now, but now I'm taking 4 and I'm subtracting the 21. Well, now that we're using calculators, I wouldn't even recommend doing the 4 minus 21 by hand. Just type it in your calculator. 4, there we go, 4 minus 21. That'll give us the numerator of negative 17 there. So I got negative 17/30. This is not simplifiable at this point. So that should be my final answer. But again, I want to check on the calculator just to make sure. So the calculator confirms that this is negative 17/30. And again, I would just have a lot more confidence in typing this into a homework or quiz or test problem, or boxing it in if I'm doing it on video. Yeah, this one's a good one. We haven't seen variables in these fractions yet, which is good. I want you guys to try this one, even though we haven't seen variables in fractions. Just what would you do? What do you think you would do? And then we'll kind of either confirm or reject your hypothesis with what we do on the problem, all right? But try this one out. Take 30 seconds and see if you can operate and simplify this, okay? 30 seconds, go. All right, hopefully you guys got this as your answer. And some of you guys may be wondering, well, how do we get that answer? Well, this is how. The denominators are already the same, right? The r's. So I'm just going to rewrite the fraction with the new denominator, r, as one fraction, right? And I keep that operation, but I take the two values, the negative 4 and the 1, and I just add them together. Well, negative 4 plus 1 is negative 3. And then, of course, we have the same size pieces. They're r size pieces. So that's what we get. And there's not really a way to check this on the calculator other than to just check that negative 4 plus 1 is negative 3, which it shows on the calculator there. So as it turns out, this is as simplified as we can make this problem. Now we like that one because the denominators were already the same. And remember, once the denominators are the same, then you can start adding and subtracting. It's only when they're different that we need to worry about. So on a problem like this one, again, just take 30 seconds and see if you can operate and simplify this one if it's necessary. 30 seconds, go. All right, let's go over this one. So on a problem like this, no matter what your numerators are, first thing you should be thinking on any problem, whether there's a variable in it or not, is since we're adding or subtracting, we need common denominators, all right? So let's find a common denominator first and then worry about those numerators. Now the denominator I'd be looking at on this one is 30, right? 15 times 2 is 30, which we've seen in this lesson already. And then 6 times 5 would be 30. So if I use a denominator of 30, that's going to make things really nice because we'd have common denominators, right? So 6 times 5 is 30. What do we do with the y? Again, it's the same idea. We're just scaling this up. Multiply it by 5 as well, just like you did with the denominator. 5 times y would be just shown as 5y. And yeah, we are adding here. And then 15 times 2 is 30, so 7 times 2 is 14. So we've scaled both fractions. They haven't changed their values, but we've changed the way they look and manipulated them in such a way that the denominators are the same, which is what we want. So the denominators being 30 is nice. Let's see what we get when we show this step here. Well, you're adding 5y and 14. Now, if we went back to, I think it was 2.1, maybe it's 2.2. If we look at a problem like this one, do we have any like terms to combine? which is what we would have asked in 2.1. And right here, I'm not seeing that these two terms in the numerator are the same, right? One of the terms has a y, the other one does not, which means we cannot combine them other than to show that they're being added. So this, as it turns out, is our final answer. And yeah, we don't know what y represents. So what are we actually multiplying 5 by? It's just that we're multiplying it by some number, which could be determined at a later time. Now, if this was an equation, it would be a whole different story. But this being an expression means that our final answer is also an expression. Yeah, if you had simplified this into 19y, it's just one step too many, right? And again, that's because the numerators here, 5y and 14, are not like terms. So yeah, when you guys are putting this in the homework, if you're using the math quiz stuff, like you should be able to type in a fraction into the homework. But if you're using the division symbol in the computer, whatever, you may have to put that in parentheses, the numerator. All right. So what about a problem like this one? Well, again, I'm going to give you guys a minute to work on this one, but remember, when we're adding or subtracting fractions, no matter what they look like, and they'll look really weird once you get into like 10, okay? But we need you guys to get this in your minds right now that whenever I add or subtract fractions, I need common denominators. So take 1 minute and see if you can simplify this one, all right? 1 minute, go. All right, hopefully that was enough time. And again, I just want to emphasize we're adding or subtracting fractions, so we need common denominators. Now, I'm going to show this with the prime factorization, hopefully to emphasize what's going on here, and then hopefully it will make more sense, all right? So the two denominators that we got are 7 and x, all right? Well, 7 by itself is prime, right? So if I list the prime factors of 7, it's just, well, 7, right? Well, what about the x? Look, I don't know anything about x other than it's just x, okay? So there are no common factors in this one. So if I wanted the least common multiple for both, well, you'd have the 7 and you'd have the x. They're just uncommon, right? So 7x, or 7 times x, that's what I need the denominators to look like, right? So I need this fraction to have a denominator of 7x, and the second fraction also to have a denominator of 7x. Well, how do I get these two denominators to look like 7x? Well, what do I have to multiply 7 by to get 7x? You'd have to multiply it by x. Well, remember though that we're not just dealing with denominators, we're also dealing with the numerators here. So you need to multiply the numerator also by x. So 1 times x would be just x. You could show the 1 as a non-phantom 1 if you'd like, just negative. Okay, don't forget that negative there. And we are adding in this case. Well, what about the x though? We got the 2 over x. Well, what do you multiply the x by? 7. If you multiplied the x by 7, you'd get 7x. So what do you multiply the 2 by? 7. 7 times 2 is 14. So now we have negative 1x over 7x plus 14 over 7x as our new expression. And we have a common denominator of 7x. So I can take the two numerators, negative 1x. On the homework, I would just show negative x, you guys, but I'm showing that phantom 1 just so we remember that it was a numerator of 1. And then we had also the numerator 14. Now, some of you may have been thinking at this point, I needed to simplify, right? Well, no, if you simplify this, then you no longer have the common denominators, which we worked so hard for. So now we need to look at we have the denominator of 7x. We need to look at the numerator now, and we have two terms, negative 1x and positive 14. But they're not like terms, so I cannot combine them, which means this is now complete. And I just want to tell you guys, if you're thinking to yourself that this looks weird, it does look weird. And I agree with you. That's just what they're looking for in this type of problem when you see it on the homework. So you type it in like this. And again, yeah, you may need some parentheses on that when you type it in the homework. But just because it looks weird doesn't mean that it can't be the answer. Or it may not feel right, but this is correct. This is now simplified because instead of dealing with the two fractions, we now have one. And if we wanted to replace an x with a value, well, I guess you can decide if that'd be easy or not. All right, so that was our three variable examples. Let's go back to one. I don't know if having three fractions with this addition and subtraction stuff makes it easier, or maybe it's not even more difficult, all right? It's just the process is still the same. Before we operate with these, we need common denominators, all right? And that's what we were trying to emphasize with the variable stuff, is that the process is still the same. And then also we can, once we have denominators that are the same, we can manipulate them like we did in that last one with the 7x, right? Like, well, you have a denominator of 7x that's the same. Now you would combine the numerators, all right? So that's kind of the purpose of those, even though they look kind of weird when we get to the end. So on a problem like this one, we need the denominators to be the same. And these ones aren't too bad, right? We got 2 5s and a 3. So hopefully we know that we could just make the denominator 15, all right? Well, I need to make all three fractions denominators of 15, right? So I'll put those in because I know that's what my target value is. And we got subtraction and addition. So 5 would need to multiply by 3 in both cases. So I'll multiply the two numerators also by 3. 3 times 3 is 9. 1 times 3 is 3. There we go. There's those two. And then the 3 I'd have to multiply by 5. So the numerator also by 5. 1 times 5 is 5. And now I have an expression of fractions, addition and subtraction, with common denominators, which is what we really need in this case when we're adding and subtracting fractions. So since I have common denominator, I can write all of this, all three fractions, as one fraction where we're adding and subtracting. But what were we adding and subtracting in the numerators? We had a 9, a 5, and a 3. So doing this operation, these two operations with the denominator 15, 9 minus 5 plus 3 is 7. Now again, that should complete the work, but let's just check on the calculator. So the calculator has confirmed that we did the work on this one correct. 7/15, and we're good. So I don't want you guys to feel intimidated by these problems. It's like, well, we've been only operating with two fractions, so suddenly there's 3, and it shouldn't matter if there's 5 or 6 or 10 fractions or 2, right? We just want you guys to remember that when you're operating with fractions, with addition or subtraction, you need common denominators. And could you have used the order of operations on this one? You could have, right? You would have done the subtraction first. Now you would have just done the 9/15 minus 5/15, which was 4/15, and then you would have needed to still change this 1/5 into 3/15. So that came out pretty convenient. if all three of them were different, you can decide if you're going to use prime factorization or just listing multiples or just multiplying the three together to get a common denominator. All right, here's one of our favorites, a word problem. Jesse has 3 1-gallon containers. The first one has 5/6 of a gallon of juice, and the second has 1/6 gallon of juice, and the third has 2/3 gallons of juice. How many total gallons of juice does Jesse have? Well, if we're looking for a total on this one, that means that we'd be combining them, right? So we have this first fraction here, 5/6. I'll try to color code these. 5/6. The next, well, I guess it'd be jugs, maybe. Yeah, containers, it says, right? The next one has 1/6 gallon of juice. And then this third container has 2/3 gallons of juice. We need a total on this, so we're just going to add these together. And we're not dealing with any weird fractions, I would say, on this one. So I just need to scale the 2/3 into sixths, which is going to make this nice. 3 times 2 is going to give us this in sixths. And so 2 times 2 would be 4. 4/6. And again, I'm emphasizing we're not changing the value of the fraction. We've only scaled it so that the denominator is the same. So we got the rest of this. So we have the common denominator of 6. And we're just adding these values together. We had 5/6, 1/6, and 4/6. So let's add these together in sixths, right? 5 plus 1 is 6. Plus 4 is 10. So adding these together, we get 10/6. But we can simplify this, right? And whenever you have a problem like this, even though it's a word problem, still look to simplify this, all right? So I'll make this fit a little bit better. And 10 and 6 are both divisible by 2, so I'm going to divide these both by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. Now, before you answer this one as 5/3, if we were to write this in somehow, the answer is not 5/3. It's a word problem. So we need to remember to label our answers. This is 5/3 gallons. That's good. And we'll be dealing more with mixed numbers in the next section. So even though we know how to change 5/3 into a mixed number, I would just keep this as an improper fraction for now. And of course, check this with the calculator, right? All right, another word problem. Rebecca picked 1/4 of a bushel of blueberries yesterday, but today she picked 5/6 of a bushel of blueberries. How much more did she pick today than yesterday? So we'll give the answer as a fraction. We'll reduce it to lowest terms, I guess, if it's necessary, which it may need to be. But in any case, how much more did she pick today than yesterday? That's a difference problem. And I'm using the word difference because difference is the operation of subtraction. So, we got how much more today than yesterday. So we're going to take today's, which was 5/6 bushels, and we're going to subtract yesterday's, and this will tell us how much more today than yesterday of a bushel of blueberries. I like blueberries. They're pretty good. Well, this is subtraction with fractions, so we need common denominators. And yeah, I'm going to use the denominator of, look, I'm going to use 24. If you used 12, that's okay, because the answer is going to be the same either way, all right? Now, why am I using 24? It's because in my mind, I just did 6 times 4. But again, if you're thinking lowest common denominator and use 12, it's still going to be the same answer, all right? So for this one, 6 times 4 is 24. So 5 times 4 is 20. So we'll do 4 times 6 on the other side there. 4 times 6 is 24. 1 times 6 is 6. And this is subtraction. So it looks like in the end this is going to be simplifiable anyways. We got a common denominator of 24, which we're subtracting 20 and 6. So 20 minus 6 is 14. So we got 14 24ths. And once we simplify this, then you get what would have been the lowest common denominator of 12. And this is 7/12. Now remember, this is a word problem, so it's really not 7/12. It's 7/12 bushels. And yeah, if you want to go the extra mile and put bushel, I don't know if it's bushels or bushel, you guys, sorry. I'm going to say bushels. Bushels of blueberries. Again, having gone the extra mile there, that's fine. Now again, I'm going to check on the calculator though. All right, find the perimeter of this rectangle. Hopefully you guys can see those fractions. We got looks like a width of 1/3 and a length of 4/3. So perimeter, if we hopefully remember this, perimeter for a rectangle or any shape really, just adding the lengths or the sides together, the outside values. So for a rectangle, we show length plus width plus length plus width. Now, I said that the length was 4/3, but it doesn't really matter. Okay, like if you said, well, I want the width to be 4/3. Just generally speaking, for math nerds like myself, we say, well, the longest side is the length. But we're not really concerned with that right now. Okay, that's more technical garbage. So I'm going to replace these. Okay, so the length, I'm going to say, is this 4/3 right there. And hopefully that's big enough to see. And then the width is 1/3. Oh, these ones already have common denominators. That's excellent. Which means we can write this whole thing with one denominator. And yes, it's all addition. All right, so we got 4 plus 1 plus 4 plus 1. So the perimeter in thirds, we got 4 plus 1 is 5, plus 4 is 9, plus 1 is 10. 10/3. So the perimeter is just 10/3. We'll clean this up a little bit. 10/3. Now, if this one was labeled, if the 1/3 and 4/3 was labeled, we would want to label the perimeter. But it's not. So, I mean, if you wanted to put units, that's fine. I'm not going to worry about it for now, though. Okay? And yeah, again, you'd want to check that on the calculator.